I am a Bitcoin activist. I am also a computer engineer. I'm a political activist as well, and I enjoy a good discourse. So I run the website Abolish the Bit License. I also run the website Outrage Democrat. I also run the website privacyboard.nyc. I also run a lot of things based on Bitcoin. And all this discourse started with the misunderstanding from a lot of politicians on how to generate a private key. So without further ado, we're going to generate a private key manually. So we're going to take Andreas' book, Mastering Bitcoin, and he wrote that in 2013, the first edition, and there is a whole paragraph on it. So I'm going to read it, starting with the private key in the form of a randomly generated number k. We multiply it by a predetermined point on the curve called the generator point g to produce another point somewhere else on the curve which corresponds to the key k. And this is specified in the SAC256K1 standard and is always the same for all key in Bitcoin. K equal k multiplied by g. Well, okay, yes, my God. I just have a headache just thinking of it. So we're going to use instead the Cenary numeral system. The Cenary numeral system is a base 6 numbering system. It's hexamal. They call it the hexamal base system. And it's very simple. I mean, it has a nice ring, a Cenary base system. So what am I going to use to generate a private key using the Cenary? So here it is in this bag. And I'm going to do that by using a dice. Here it is. That's my Cenary base system. You can Wikipedia what it means. It's just the same. It's a simple dice. So as an asshole, I have to be pedantic. And so, just to create it, you take 100 of those, you put them in the bag, and you just dump them in a holding, in a placeholder. You make a little square of 10 dice over 10 dice. That's make 100. That make it simple. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And that was the private key. And that's why Bitcoin, it's a commodity. Because no matter what law is passed, nobody's going to forbid me to use any random generator. Randomness is everywhere. It's in the sky. It's in the air. It's everywhere. So there is a good website that explains what random is. Random.org. So while I'm preparing my square here, you can read a little bit about it. Or you can say, well, Theo, you're full of shit as usual. Well, that's fine. I'm full of shit. But that's what makes a commodity. It's something that exists. It's based on the element. It's based on the table of element. You can go there on the internet, you'll find the table of element. Start with the hydrogen, with one layer electron around the proton and nucleus, and I forgot all my chemistry class, but that's what it is. So Bitcoin is the first intangible commodity ever created for the internet. So if you can pass a law prohibiting me to do that, you can prohibit Bitcoin to exist. So, because you cannot do that. You cannot make any law. If you make a law, the commodity becomes the asset. But Bitcoin is the commodity. And all commodity are asset. All assets are not commodity. Because intangible asset, are intellectual property, the logo, Nike logo, the Coca-Cola logo. And what protects those logos from being used is the law. And that's what they are asset. Bitcoin is pure math and randomness. So we'll go over it. So there is a generator that we're going to use that was created by William Swanson. So we'll give him his due. I mean, you can see the script is very simple. So one thing with the dice, all the numbers start at 1 and finish at 6. So for our example, we need number to do the mathematical conversion. We need to use the same numbers. So 0, 1, 2, 3, 4, 5, 6, the same numeration. So every time we get a 1, we make it a 0. Every time we get a 2, we make it a 1. We just remove 1 to the number we get. And we just write them one by one by one, one after the other. So we're going to do this. You can use any format you want. You can go from the right to the left. If you read Arabic, you can go from the left to the right. If you read Japanese, you can go from top to bottom, left to right, right to left, bottom, either direction you want. The only thing is you need to remember it, because I doubt that if you throw the dice a second time, you'll ever find those numbers again. So that's what makes it a very private key. And we'll go over the elliptic curve cryptography after in another video, but I just wanted to show you how you go from a private key to a public key that you recognize on everybody. And yes, I know this is version 1 of the private key, and I'm going to go from right to left. So we're going to start. So we have a 4. So 4, 4, 4, 3, 2, 5, 2, 2, 1, 4, 4, 5, 5, 1, 1, 3, 5, 3, 3, 2, 6, 4, 6, 6, 4, 5, 6, 5, 5, 6, 4, 5, 2, 3, 5, 5, 6, 1, 6, 6, 4, 3, 3, 4, 2, 1, 6, 1, 5, 2, 1, 4, 2, 4, 4, 4, 2, 6, 6, 6, 4, 5, 4, 6, 2, 1, 4, 5, 2, 4, 1, 3, 3, 6, 5, 3, 1, 3, 4, 6, 6, 4, 5, 4, 2, 5, 3, 1, 5, 6, 2, 6, 3, 6, 5, 6, 3, 1, 4, 1. And we're going to enter, and now we have here, as you can see, a private key. And this is called an elliptic curve. This is called an elliptic curve digital signature algorithm. That's what we're going to use to transform our private key to a public key. So we'll go over that in another video to do it manually. But basically what we're doing is we're just taking our number in base 6 and converting it to base 16, which is hexadecimal. We enter it on the website. So what we're going to do is we're going to change the number here. We're going to change this number by the number we got from the previous program, 612 B7567 E51 D58 A58 2E A89 DE 128 1 AD 1 EB9 D2. Here it is. We're going to send it. Done. It has transformed it. He gave me the public EDS elliptic curve key. He did some SHA-256. He did some hashes. All this is fluff. All this is fluff. What's important is we get to the base 58 encoding this number. So if we go here, and then we go here, blockchain.info, we enter that key, oops, we enter that key here, we get a private key. I hope you found this video instructive. This is the first one explaining the basic principle on how to get from a random number to a public key. The public key has been, as you can see, the public key has been mischaracterized as everything from a wallet to a random number of uppercase, lowercase character, anything. We'll go on more detail on the elliptic curve digital signature algorithm in another video as well. That will explain that the public key is just a representation of a x and y, a point on an x and y graph that we all agree on, and that's what is the consensus. But I just wanted to show with this video how the ULC definition basically is completely wrong on what virtual currency is. As it says, virtual currency is intangible. Well, yes, it's an intangible commodity. Its manifestation is in the form of lengthy computer addresses referred to as private key and public key. So basically a private key is a random number, and the public key is just a point on a graph that you can only work one way. You can go from a private key to a public key, but from a public key you'll never be able to go back to a private key. We'll talk about that in the next video as well. But the definition that the ULC has come up, do you think, based on what you just learned today, that it will stand the First Amendment? I will also work on the ULC definition of mining, because they talk about solving a puzzle. Bitcoin is not about solving a puzzle. It's mining. That's another misnomer. Mining is not a puzzle. It's not solving any puzzle. We're not solving anything. We're just taking a random number, we put it in the computer, and if it's the first one to have a certain characteristic, it wins. So let it be disruptive and try to figure out how to regulate it, but the ULC bill is not it.